The clarifications corner for this one is a separate unlisted video. I have cleaned up infrastructure, or the architecture rather, of my leg. There's custom registers now, there's custom decoders, there's improvements in... No, I don't think there's any improvements in the ALU. There's improvements in the conditional block, as well as some talk about optimizations, NAND scores and stuff, and optimizations inside of these things. So if you're into that, you can go check out the video. Up in the top right corner should be a pop-up. And I am going to proceed with the next level, which for me is definitely going to be RAM. And in fact, I'll probably do this whole section until functions before I proceed with anything else, just because I'm really interested in RAM, and I feel like that's probably the biggest feature the architecture is currently lacking. So let's go. Add a RAM block, lowercase RAM now, so the computer can address the 56 additional bytes of memory. You need a way to decide which of the 256 bytes inside the RAM we are addressing. Sure. Select a register and wire it up, so its value always selects the RAM address. When you'll later want to load or save to RAM, you will have to first copy the RAM address to this register. Okay. Why though? Why would I want to hardwire it to... Why on earth would I want to hardwire my RAM to a particular register? Why not use one of these lines? Or a million other options I have? Any of the million. In this test, first copy the input 32 times and store, well, yeah, after you have loaded the 32 values, output them in the same order. Outputting before you have read all the inputs will fail the level. That's fine. That's more of a problem statement. It's really weird that they want me to hardwire a single register. Why would I do that? I mean, I understand why the address would want to be in a register as opposed to specified as a compile time constant in my instruction, even though I still have a lot of free real estate in these instructions, right? Bit 16 is completely unused, bit 8 is completely unused, and this means that if bit 16 or bit 8 is set, all the other 3 bytes are free, you know, I cannot even pronounce it. Interpretation. I can interpret them any way I want. Or, for example, in these 3 bits, or in these 3 bytes, I actually still only use the first 3 bits because I have addresses up to 7, right? I can use more than 3 bits if I'm in immediate mode, as set by these bits. But if I'm not in immediate mode, then I'm kind of in address mode, and every value above 7 remains completely unused. So I could, for example, put my RAM down, RAM, and whenever the value is greater than 7, I don't go in here, I instead go into RAM. Also, I think I unlocked fancier RAM. What are these? Why do they have darker things in the middle? Why do I have 4? Okay, what does it say? Yeah, why do I have 4 outputs and why do I have 4 save values? Does this mean I'm gonna be able to read 4 bytes at a time? Also, there's a bunch here. There's different sizes. as well as data width. How do I even use this? It wasn't this complicated before. We just jump back here. Yeah, see? This is the RAM I understood. This is the RAM I saw. We have load, we have save, you know, our instruction, we have address by which to save or load, and we have the value which we can save. And we have a single output for loading. So this is much more understandable. So I'm guessing these three down here, yeah. They're just extra stuff which I am not yet supposed to understand, I assume. Okay, so I can just ignore them for now. Let's see. So here's what I'm thinking. I think I don't want to rush it, and instead I would probably prefer to write down everything that relates to the operations I want. So I want two operations, right? I want save and I want load, right? The question is, how do I specify exactly what I save and what I load using what I have? So for save, okay, give me a moment. So for save, what I'm going to want, first of all, I need to save, I need to enable the save pin, right? So save pin, we are in fact saving. I need to provide an address, right? Address, and I need to provide value. And for load, I'm gonna want to just enable the load pin. And, well, wait, that's not all, actually. We are in fact loading. But for load, in addition to address, provide RAM address, right? Load save to provide value which to save, and now for load I need to provide address read from or load from, and I also need to provide, this is provide RAM address, I will also need to provide leg address load to, right? Does problem statement say anything about this? The way to decide which we are addressing? Yeah, so this is my first, or this is my second thing. I need to provide RAM address. Wire it up. No, that's all. Copy from input 32 times. Okay, so this is actually optional. Provide leg address to load to. It's kind of optional. I could instead, so it's one of two things. Either I provide a leg register address to load to, or I could just load to bus potentially and use it in some other way. So for example, I could say that my loaded value from RAM is going to be indistinguishable from a value loaded from register in a way. And by the way, for all these, before I even decide whether I'm saving or loading, I also need to, you know, route to RAM, you know, or something like decide on using RAM. So this is another part of my instruction. I need to specify that I am in fact doing something with RAM. Which, I mean, so save versus load pin, these two. These could be 1 bit, right? Like if the bit is off, then we're loading, for example. If the bit is on, we're saving. That would be fairly simple, and I could just use a 1-bit decoder here. And perhaps I will always want a RAM address. Okay, so actually, if you take a look down here, I either provide the leg address or load to bus, and here provide value kind of unfolds to, you know, provide leg register address save from, you know, or I can just save from bus. There's a lot of freedom left to me. It seems like there's a lot of ways I could implement this potentially. Why is my game laggy? Is it noticeable in videos? It just seems to stutter sometimes. I'm gonna try and do something about it. Should be fixed now. So yeah, they really weren't joking when they said that leg would be less specified. There would be less hand holding from now on. And this is quite a daunting task, because of course there's a lot of options for how I could implement what's asked, but I'm not sure which is good and which isn't. So for example, one way I can see is I could always have a piece of wire. Why is this weird green? This is unexpected. Why is this a weird green? Huh. Does that mean anything? Does this mean there's like a slow wire or something? Because yeah, that is what I imagine RAM operations to be, much slower than reading and writing to and from registers. So I was going to say, if we assume RAM to be an immediate operation in the same sense as we assume registers to be, or everything else in here. So we could read from RAM in 1 tick. If we assume that was true, I could have pretty much just another line, you know, next to these guys, which is just always loaded from RAM. I can always, on every tick, I can always load RAM from somewhere. And then I'll have, for example, bit 16 as my save to RAM. So if bit 16 is on, then all of a sudden I switch to save mode. Well, there's nothing stopping me from trying to wire it up. Is there not? I can try this. So we have bit 16. And let's say this is my RAM mode. So this is gonna be, I'm gonna decide on using RAM, right? This is the first question we ask. Then we decide on save versus load mode. Right, and I'm gonna combine deciding on using RAM and enabling save pin versus enabling load pin, I'm just basically always using RAM. That's my current idea, which is probably not good, but I want to find out why. So yeah, I decide I'm always using RAM, but by default, I'm always loading. So I put a decoder here, like so. I'm always loading. And if this guy is on, then I'm actually saving. Which, by the way, what happens if I don't load? What happens, first of all, what happens to this RAM if load pin is off? Well, it looks like it's still loaded. Okay, can I please try saving something? Let's try just saving something. So let's put a bunch of constants here. Let's take 8-bit constants. I think I just need 2, and let's try saving the number. So let's save to address 0. Is this address? Yes. Let's save to address 0, and let's save the number, whatever, 17. Let's enable the save pin constantly. Just experimenting. And let's run a tick. 17 is saved. But I'm not reading. What if I now add an on here? It looks like I will immediately read from RAM. So, okay, how about nah, can't be bothered creating a mock setup for this. Let's just try implementing this. So I'm gonna say, just like I do here. Again, I want to find out why not. Why not always load? Right? I can always load, it seems like. And then this guy just decides if I'm saving, and it's not forbidden to save and load at the same time for RAM, just the way it is for register. You can at the same time save and load from register. And then address. Address. Well, I mean, there's a million ways I could implement this addressing scheme. I'm told to just use a register, which would be the easiest thing in the world to do. But I really don't understand why. Why would I just use a register and not one of these wires? I don't get it. I don't get it. Right? Like what right now, take a look here. Our problem statement says I need to copy from input 32 times. This means that I'm gonna have to use addresses 0 through 31, right? And yeah, then I'm gonna have to reuse them. But if my address is in a register, then somehow I'm gonna have to every time increment my register by 1, right? And that sucks. Incrementing a register sucks. However, if I implement a more, reliable scheme where I load from one of these guys, or not reliable, a more modular, I don't know what to call it, where I actually select my RAM address based on these guys, which I could even envision using a mux here. So you know, something along these lines. Oh goodness. You know, like this, and then somehow I decide which of these will be my address, right? It's not enough screen, as always. So if I did this, then I could actually significantly optimize my solution to this problem with 32 things. If I need to increment my RAM value by 1 every tick, then I could just use my program counter, could I not? I could just load the address from program counter into here, or into here, which is already present as part of my infrastructure. And yeah, I could just supply it, provide it like so. Provide the address based on my program counter. I mean, then when I need to output them, I won't be able to use my program counter because I need it to keep ticking. I can't just keep doing the same thing over and over again. Although I kinda could. No. I don't know. Would I even be able to... So let's see. Can I fit... Let's say if I were to use the program counter as my address, could I fit a complete load from input and save into RAM into a single tick in a single instruction? So what would I want to use? Well, I have my 16th bit, right? I enabled my 16th bit. And then I say, well, actually, that's about right. Wait, I don't want a mux here. I can just, and I think that would be better, I can say that the value I'm loading is my input 2, right? What would normally be input 2, and the address is my input 1. So then I could just specify, well, yeah, I can just work with RAM the same way I would with a register. Right? I just these guys will be specified in my input output, or input 1, input 2 bytes in these guys. And I could even connect this to my bus. Well, since we're making an offshoot, let's say it's gonna be something like this, right? And that would be, it can be saved to my third argument. And then the same infrastructure of, for example, immediate values, I would be able to read from RAM by an immediate value immediately. Why not? Why is this bad? I don't understand. I expect this to be bad. This is not what's asked of me. I'm supposed to select my RAM address based on the single register. Okay, I'll give this a couple more moments. Well, one thing that's definitely going to break is my ALU. I did notice this when I was wiring the 32nd bit, this one. So right now, if we take a look here, basically any operation that does not have bit 32 is considered to be an arithmetic operation. And so my ALU will always be working. And basically, yeah, my computer runs in two modes, right? It either does arithmetic or it does this. Which actually, wait. I was told that I can use arithmetic as my mov, but not for RAM operations. Right, so there would be a clash here, which I can definitely get rid of. I can definitely fix that by not just looking at the 32nd bit and having two modes of operation, conditional and arithmetic. I could have four modes of operation. Okay, wait, but this is not... there's so much to consider here. There's so many options I can do this. There's so many options. I can't decide. Right, so I cannot currently use my RAM with this kind of wiring. I cannot use RAM as an argument, right? It's only gonna be loaded into output. So I would have to first move a thing from RAM to a register and then work with the register. Could I perhaps wire it so that I'm also able to use RAM values as my arguments? So basically I would want this connected to one of these lines, the purple or blue. Yes, I know right now this is a circuit dependency. Or whatever, short circuit can be a lot of things. There's way too many options. See, I would just say, let's try this and see where it leads us. But I feel like there's a very large cost to trying things out here. The reason being, of course, is the fact that we have no assembly. And I'm gonna have to update all of my assembly commands if I change my architecture, right? If I start adding assembly codes, I'm gonna be in trouble when I decide to switch up my architecture. And I kind of want to get it first try. Well, okay. There's one thing I'm thinking now. This connection, this part, where the output of my RAM is wired into my output bus component, actually goes against the convention of other things I currently have. If we take a look, really, whenever I load from registers as well as actually from input, I never load values into my output. The way output gets populated is always using the ALU. So there's also this, so I can have an immediate output, but I can have everything immediate. And this was also related to conditions, as far as I remember, if I recall correctly. Actually, let's go back a little bit and let's take a look at how exactly that worked, because I already forgot. Yeah, for if statements, the byte represents jump address. Right, so yeah, I want immediate jumps using constants from my program. Right, so yeah, back to what I was saying. I'm never actually loading things directly into the output, and with RAM, For some reason I decided that I would. Which, again, not necessarily a problem. This could be seen as an operation because RAM is a very separate part of the computer. But seeing as RAM is storage, and I want to treat RAM in a similar way as I treat registers, it would kind of make more sense if I was perhaps saving the value the way I do for registers. If perhaps for my RAM, I had my save value routed from green, you know, like so. I was saving value. And instead of outputting to green, I would be outputting to, well, one of the lines, either blue or, well, light or dark blue. Again, I am fully aware that this is not dark blue, but this is the closest I have to it. So I'm gonna keep calling it dark blue. I want light blue and dark blue to signify the two different inputs. Signify that they're the same thing except different. Yeah, so I could even decide, you know, I could even have this kind of setup of two switches from my output, and I would decide where I go based on something else. And then what is my address? Yeah, and then I would have, well, see, again, I do not like the idea of hardwiring the address. It's probably gonna turn out to be a good idea because that's what I'm told to do. And if I'm told to do this, then I assume it might even be the case in actual modern architectures. But I just cannot see why. And I want to understand the reasons for doing things. Well, actually, it seems like I might not actually be able to do this and to have my value read from RAM leading to green or to blue, or this to light to dark blue, while my green line is my value to be saved. Wait, actually, no, that's not a problem. See, I was going to say that if I'm loading an argument from RAM, right? So if I'm doing blue as output from RAM, then green depends on these outputs, right? On these arguments through the ALU. And therefore I would have a circular dependency, right? I would need to first load from RAM before I save to RAM, but this is actually only a problem when I am saving a value. But I could separate my save and load tasks, right? And I would have no output from here. I could have, so I could, well, yeah, I could keep this on just like I do for in, but I could bar this with switches, this output. All right, so if I am in save mode, then I save from this, and these guys are not, they are guaranteed to not be loaded from RAM, so I have no circular dependency. And if I am in load mode, then I do load, but I don't save, and again, we don't have a circular dependency. So okay, but what if so let's say I hardwire my argument 1 to be my address, and I hardwire my argument 2 to be what's loaded. Is this a problem? Doesn't seem to be right now. Right, so I'm loading by address from argument 1 into... Yes, this would work, but this seems pointless again, because I will have... Basically, I will have different types in my two arguments, right? In my light blue argument, I will have a pointer. I will have my address, while in the output, I will have a value. And there's nothing useful I can do with these things, right? My ALU being applied to them is going to be useless, because I'm going to be combining an address and what's under that address with an arithmetic operation, which makes no sense. So this green line will be nonsensical in all such loads. So that doesn't seem like a good idea either. Which I guess does suggest that loading from a constant address, from hardwiring a register like so, is perhaps a good idea. And so then I could... do I want to switch this guy or not? Right. Do I want this structure for my RAM? Do I want to be able to load into argument 1 or argument 2, depending on something in the opcode? Or do I just hardwire it to, for example, load into the first arg? There's so many options here. There's so many options. It's daunting. I don't necessarily even have to use parts of my opcode to tell me that I'm referring to RAM, because I still have so much free space in my instructions, right? I only have, of my arguments in pointer mode, I only use 3 bits. So I still have, what is it, 5 bits completely unused. So for example, I could say that I am in RAM mode, or like in save to RAM mode, if my destination byte, you know, this one, if this is larger than 7, greater than 7, for example 8, I could just say that RAM is my register number 8. Right? What's stopping me from doing that? I could say that if we have an 8, then please save here, and this is gonna be, you know, something along these lines. Of course, this is not possible right now, but you know, this. It's a possible setup. I could do this. And I could, in the same way, say that 8 here is load from RAM, as well as this is load from RAM. Maybe that's a better solution, right? And then I will have these here, you know. I will... well, you get the idea, right? I will have this one and this one, and I will have my stuff, you know. And then my address is indeed gonna be wherever it is. Yeah, that guy, or, you know, some register. This is a possibility. And then load. Well, again, load is always on for me. because of how I do my switches, you know, because of these. And then my save value is going to be taken from the green line, you know, in the same way down below, piped into here. Right? I could treat my RAM as just an 8th register. I could even expand my 3-bit decoders to 4-bit decoders, and I would have 16 you know, lines here. And I would be prepared for adding 7 more RAM blocks or 7 more of whatever storage devices I want. Why not? Or do I not want to do this? Do I want to treat RAM specially because RAM is slow? It's kind of frustrating, actually. I don't know. I don't think I can make this decision based on the information I have. This is very, very sparse. Add a RAM block. Select the register and wire it up. Value always selects the RAM address. Copy the RAM address to this register, yeah. Well, I mean, this suggestion kind of exists within my current paradigm of treating everything as a register, you know. In Linux, everything is a file, and in MyLeg, everything is a register. So I'm inclined to implement this. Just maybe make it temporary, you know, because I only need to care about the 8th bit, and 8 is just a bit I can destruct, right? This is 8. I don't need a decoder. I don't need to expand this decoder. I just check whether 8 is on in all 3 of these. Well, for each one of these 3, I can check if it's on and do the thing. Should I do that? I probably will. I don't know if this is a good idea. I mean, there will be an issue with malformed instructions if I do this, because, yeah, I will have, by using this kind of thing, by using a decoder, or by using a splitter, as opposed to scaling my decoders to 18 or 16 possible values, I will have an issue when I'm both performing a RAM operation under 8 and I am doing something else with these things. So for example, if my address is 9, right, this will mean that both I am loading from RAM, because 8 will be on, but also 1 will be on, which will mean that I am also loading from, you know, this. Oh, actually, in fact, right, this will always be a problem because even 0 is an address of the 0th register, right? So I kind of have to scale my decoders up to decode 16. Scale them to 4-bit decoders, which I can do, no problem. But do I even want to? Not really. Because, you know, I'm already starting to think about multi-threaded or multi-core processors, as well as really the delay on accessing RAM, because if my RAM operation is just a, what do you call it? halting. You know, if I actually have to hold my processor for the entire time it takes to go to RAM and bring a thing back from RAM, which would necessarily be the case in this kind of setup, right? That's gonna be crazy inefficient. So I don't imagine that's what's done in the real world, though. Again, how far am I from being similar to something real world? Is it even possible to implement here? This is gonna be an entire video of me just complaining about RAM. All right. Enough of that. I think I'm just gonna go for what I'm used to. And I'm gonna go for this, you know. I'll put RAM in line with my registers. I will upgrade to 16-bit decoders, or 4-bit decoders. I have been complaining about underutilizing the spaces in my address bytes. And we'll see where that brings me, but I'll do that in a separate schematic. So I'll call it leg 16 or something. I don't know. But I think the implementation of a 16-bit decoder should be left off camera. So next time you see me, expect to see me with a 16-bit decoder in my hands. Like this one. Well, yeah, in the process of making these, I realized this was probably utter insanity. There's no way this is what's expected of me. But I'm still gonna roll with it because I just want to do something. And if I don't do this, I'm gonna get stuck on this level forever. So yeah, I mean, they do look cool, and I have used, so if you take a look, this is a 4-bit decoder. Inside it, I used 2-bit decoders, and I actually implemented custom decoders for everything. So I have a custom 3-bit decoder without a disabled pin, but yeah, it's all the same kind of structure, and a larger decoder is just a combination of smaller decoders. So I guess let's use it in leg. We're gonna have huge lines here, but other than that, everything should stay the same. I'm gonna create a copy of my leg. I'm gonna call it leg 16. Come on then. Yeah. And I'm just gonna upgrade these decoders. Oh, actually, I still need to implement the pin disabling mechanisms for my custom components. Well, I'll do that, and also I will space this out and replace the 8-bit decoders with 16-bit decoders. All right. Well, here's the fat leg 16. And it's ready for RAM. This is a terrible idea. This is a terrible idea. I just don't know why. I'm gonna find out. I'm gonna separate the clock from the bus, just for aesthetic reasons, I guess. All right, so what do we want to do? You want to, first of all, we want to extend these guys to cover our RAM. And I'm going to want to connect 8th bit to load. And wait, and not to load, to save. to save. Right? Yeah. It's a bit of our output to save. I'm gonna want to pipe save into save value, or I'm gonna have to pipe, you know, the output line of the bus. I'm gonna do the same trick I did with in. I still don't understand why that's a problem. So I also don't understand why this is a problem. Yeah, and I'm gonna want more space, it looks like, because RAM is huge. Not even FATLEG 16 can accommodate it. Yeah, and I'm gonna want my double switch setup over here. Let's put it on in line. Right, I will want to wire this address somewhere. Not yet sure where. Why is the switch not pasted correctly? Okay, now it is. So this is our output, and depending on whether we are loading... Oh, goodness. So, like this, and this guy will lead to blue. And like this, hit 8 into here. Now my RAM is officially a register. Only question is, what do I use as my address? Yeah, I'm thinking just register 1, except I will need to add an always on out pin, which is no problem. I even left some space for it. 8-bit output. Well, let's put it down below. No. Let's put it in front. No. Here. Yeah, cool. So this should do. And we'll have our always on output in this direction. I don't know. Always on out. I don't know. Now let's just call it out. Out 1, out 2. All right. So now we have these all over the place. And I can just connect. No. What is up with these green wires for RAM? I'm gonna wire this all up, and then I'm immediately going to find out that this is a terrible idea because these green wires meant something I didn't understand. And there is some kind of delay or something, and it's all gonna be broken. But, well, I mean, right now, it all looks good. And we can proceed with defining assembly. Yeah. This is just gonna be, because now we have actual bytes setting my inputs and outputs, my sources and destinations. So I won't need to use the OR trick, bitwise OR. And I won't also need to use the from A and to A separation of buffers. So I'm literally gonna have, this is gonna be called my buffer A. This is gonna be my B, C, D, E. I'm gonna have clock or something. Gonna have IO. And this can be called RAM. And I'm literally gonna have mov RAM somewhere. I mean, this seems good from a design perspective, but seems horribly wrong from hardware perspective. Well, okay. Let's get going. Assembly code. Oh no. Oh no. Yeah, do I want to first populate this with rules? By the way, I have played around with this off camera a little bit, and I still don't understand how exactly I'm supposed to define rules, except, you know, ones that involve this bit. See, if I cannot drag the left boundary of this bracket. So how do I define a rule for these three? Or do I have to start with this? Like, no, new rule. What is happening? Oh, wait a minute. New rule. Oh, I do it here. Okay, I'm probably gonna have to. Yeah, so let's say this is our opcodes. Then this, oops, instructions. If this is our opcode, then this is gonna be immediate 1, right? Then we're gonna have immediate 2, immediate 2, right? This is gonna be bit condition, or this is actually if. It's kind of conditional mode. It's more than an if, right? We also overwrite our clock. Yeah, and then if we are in, well, if I'm in condition mode, wait, I don't understand. So I can't flip this bit, but this rule, or can I specify multiple brackets? Doesn't look like it. So what's up with my conditions? Oh, I cannot look it up because the window closes. Wow, this is annoying. Should I reread the manual page? If the bit pattern matches a row, the label will be shown. Oh, okay. Okay, so if... Okay. Okay, I think I get it. I think I get it. Yeah, so if... Right, if I enable this, yeah, the new rule. Yeah, but condition is always shown. Okay, so this is gonna be some ifs. All right, I'm gonna want to populate this off camera, I think, for opcodes at least. Yeah. Okay, be right back. All right, I implemented the table of opcodes. So yeah, that's actually correct. A completely zeroed out opcode is an add. We have conditions, we have immediate, you know, there's different conditions, unsigned, less than, equals, not equals, all sorts of things. And now that I've understood how this works, I have a new question. Why on earth can I move this? Is this a bug? It looks like a bug, especially in this configuration. Right? I can move this stuff around. And these bits are still unused. Okay. So I guess let's get to solving the problem. But before we can do that, we're gonna have to implement our assembly all over again. Okay, well, I've actually been thinking about this, and I no longer have a mov operator at all. It's not even possible for me to do mov. Because mov is pretty much necessarily 2 bytes, right? I have to specify add immediate 0, well, something along those lines, my register, and my, my source and my destination. So add im0 is actually mov. Okay, well, let's start adding some assembly codes. Let's begin with, let's begin with addition. Call this add. I think let's also continue using the bitwise OR trick, and let's call this one immediate 1, or did I use uppercase on add? I don't want to. I want add to be lowercase. Lowercase add. Let's say immediate 1, something like this, or just I1, yeah, to be short. Let's do I2. Now we have if. And again, I'm going to be able to OR my if with my conditions. So if, I already have add, well, let's implement everything. Add sub. Can I save multiple aliases for the same code is a question, because sub, depending on whether we're in addition or condition mode, it's both sub and it's also in eq, not equal. It looks like I can. Okay, well, don't really care for this much yet. I can add things later. What else do I need? I definitely need to save my, to save my register addresses. So this is gonna be A. Let's go for B. Let's do C. Let's do D. E. A, B, C, D, E, F. Wait a minute, I don't have that many registers. I only have 1, 2, 3, 4, 5, 6. Yeah, I only have 6. And F is actually gonna be, or not F, A, B, C, D, E, F, G is actually not gonna be G, it's gonna be, what do I call it? Is it a clock? I've been calling it clock sometimes. It is really the program counter. I'll go look up whether a clock and the program counter are the same thing. I expect them to not be, but I'll still look it up. Yeah, no, it's not a clock. Although, intuitively it does feel like a clock. It keeps ticking. But I did find the perfect name for it. It's called an instruction address register. IAR. Lovely. Lovely. Okay, so IAR is gonna be my, wait a minute, 7? Wait a minute, that's not right. Oh, 0. Did I start at 1? Don't tell me I started at 1 and I'm gonna have to rename everything now. What's my A? Oh no. Okay. So let's just shift letters. Let's say A is B. Let's remove A. B, correct. C is actually D. I'll do this. Done. So instruction address register is our 6. 0, 1, 2, 3, 4, 5, 6. Yes, that's correct. And 7 is, guess I'll call it IO. I don't know. It is IO in my infrastructure, or in my architecture. I have combined them into one thing. So let's call it IO. And it's number 7. Okay, cool. And now I also have number 8, which is RAM. Cool. Okay, so What else do I want? What else do I want? I want more jumps. Wait, my if is actually a jump, right? Yeah, I necessarily jump. Well, not necessarily, but if allows me to jump. Let's go back and I keep forgetting how the if thing operates. No, not opcodes, conditions. Right, argument 1, argument 2, jump address. Okay. So an unconditional jump is gonna be if equal 0, 0 address. Right? Okay. Yeah, no, I'm gonna go all in on the OR trick, and I'm gonna make them modular. Where do I go? So I'm gonna rename my if into jump. If is no longer an if, you are now a jump. Let's delete the if. How's the add doing? Yeah, add is okay. So let's take a look. If equals, so this is also EQ. This is going to be not EQ. It's probably easier to just save everything. Unsigned less than. Yeah, I'll just go over every instruction so I have them all, and I'll be back. All right, should be done. Probably made a few mistakes here and there. Guess I'll find out, but yeah. This should be most of my instruction set. So for example, if I want to unconditionally jump now, then I do label whatever, and then I say X, and then I say immediate 1, immediate 2, jump equals 0, 0. Oh, actually, yeah, X I put at the end. This is horrible. This is absolutely horrible. I agree. I agree, this is terrible. But the problem is I cannot save multi-byte things, right? I would like to call this a jump. The same way as, for example, I will have, instead of my mov, right? So this is my jump. Now, instead of my mov, I'm gonna have, for example, immediate 1, add, and I'm gonna be adding 0 to my address. So from, src destination, right? But I would like to call this immediate 1 add 0. I would like to call this a mov. Yeah, this is more like jump X, and this is mov src dst. Right? This sucks. Can I define multi-byte constants, perhaps? Const. Nah, no way. Const jump. No, const mov. I 1 or add 0. See? No. This sucks. I don't like this. I don't like this. But it's kind of the best I have, to be honest. Okay, well, you know what? Let's just test that something works first, and then we're gonna worry about assembly later. So let's just try. Our RAM address is 0. Let's just try loading a bunch of things into RAM. So we're gonna be, what are we gonna be doing? We're gonna be, oh, goodness me. So I need to load from input. So I need to move IO to RAM, right? Which means I need to immediate one add 0 to IO to RAM, right? This is gonna be move load one input into RAM. So, well, let's just run it. Did it run? Did I save something to RAM? Oh, I did. How cool. Okay. How about I load something else? So now that we have loaded, we want to plus plus this guy, which I can do in a single operation. It will be, again, immediate one add 1 A, right? Let's see. What? Okay, now this is at 1. And I can repeat my RAM load. So let's just put this in an unconditional loop for now. Okay, load to RAM, or rather, read to RAM. RAM plus plus. Yeah. Maybe there's a cool name for RAM pointer. RAM pointer plus plus, really, but okay. And now let's say label loop, and we're gonna be, oh my goodness. Immediate one, immediate two, jump equal 0, 0. Unconditional jump. Loop. Let's see how this goes. Let's see what this looks like. Let's see if we load 32 different things into RAM. Yeah, see, I think this is the point where this on finally comes to bite me in the butt. Because if we take a look here really closely, I take multiple ticks to load the next value, but this thing skips over a value while I'm doing stuff, right? So let's reset. And let's say, okay, we're starting. So I loaded one thing, but now I'm doing bookkeeping. I need to do plus plus, right? So while I'm doing plus plus, the input is now 216. And I would expect to load under pointer 1 in RAM, under offset 1. I would expect to load 216, but I think by the time I start loading, this 216 will be gone. Yeah, and we're now looking at 20, and I haven't loaded anything. Oh, it's, yeah, even more stuff happens. Now I need to jump back in my loop. Yeah, and even two things happen. So I am actually loading way less than I should have been. Yeah. So instead of 32, I loaded something like 10, right? Or 11 or 10 divided by 3. I load every third tick while I should have been loading every tick. So I'm gonna need to get rid of this on after all. Okay, well, again, let's just apply a quick hack for now. Because I don't have that much time left today. So I will be loading this if, well, an OR of these guys is true, right? So let's just put a quick OR, plop a quick OR in here. Let's just OR them together. So 1, 2, 3. Now we should be correctly loading 32 values. Let's take a look. Let's take a look here. It's 0 now. Oh, yeah, it's 0 because I'm not loading anything from it. It's off. 216, yes, that's the next one, 20. Cool. So how many do we have in a row? 1, 2, 3, 4, 8. It looks like 16. So I expect 2 rows of stuff. Cool. Yeah, we are correctly loading. Now I just need to, well, no problem. Instead of looping always, let's call this the read loop, right? Read. And let's say I'm gonna be reading until this thing reaches 31. So immediate 1, let's say, equal 31, but not, we're gonna be comparing register A. Right, so we're gonna be comparing register A to 31. I kind of like comparing A to 31 as opposed to 31 to A, so let's do immediate 2. And I think this should stop my loop, and we should be able to proceed, at which point I can just say, oh goodness, I mean, immediate 1, immediate 2, add 0, 32, 32, 0 or something, put it into register A. Oh, except not 0, not 32, but 0, right? I want to reset my counter because I want to start from the start. And now label right. We're just gonna be doing add. I should probably, yeah, I probably will reduce this because this is a common pattern. I should reduce these kinds of things, but let's just use this for now. So I am doing what? I'm gonna be writing to output, so something to IO. And what am I writing? Oh, it's not immediate 2, it's I'm just doing a mob. So 0, and then I mob my RAM to IO. And then I do RAM++ again. Same thing, right? And then I mean unconditional jump because I don't care. Well, might as well stop looping after. Yeah. Except not read, but write. Looks good. Seems okay to me. Let's try it. Wrong. Okay, why? Something went wrong. Why? Why did it skip this guy? Let's restart. Let's take a look here. We skip. Why? Immediate 2, 31. So I'm comparing 8 to 31. I should have jumped. Wait. Oh, if it's equal. I need not equal. Sorry. Yeah. Repeat this until equal 31. Sure. Cool. Now let's take a look here. Wrong. Why? I did reset my pointer. You need to read all the bytes first. Did I not? Oh, 30. Wait. I started from 1. Why is... Oh, sorry. I started from 0. When A is 30. Oh, right. Because... Okay. Sure. No problem. 32. Yeah, because I still... Once it's 31, I still need to load the 30 first, air quotes, and then I stop. So let's try this now. We load. And then we write. Success. I could speed this up substantially using a very simple trick. I'm not sure what it's called actually. Duff's device comes into mind, but that's just an instance of this. I'm gonna look it up. A very intuitive name. It's called loop unrolling. So yeah, all I do is to reduce the number of jumps I make. I can just copy this. I mean, the most efficient way for me to go about this would be to literally copy this 32 times. But I'm not gonna go that far. But I can, oops, come on, copy this, Control C. So we can do 4 times, for example, right? And we have now decreased the number of loops we're gonna have to make from the number of these jumps we're gonna have to make 4 times, right? And I can do the same here. So this is a trade-off between program size versus program speed. It should be significantly faster now. Yep. Yeah, and it's especially helpful because we have these nice numbers, 32. Okay, this is so slow. I mean, it should just fly by until 10 kilohertz. Yeah, no problem. Okay. Low gate cost, but slow memory. Well, see, I don't know. I don't feel how slow it is. I don't have any visible effects to show me that it's slow. Maybe it's literally slightly slower, like in the game. Maybe a tick involving RAM will just take longer. But I can't feel the difference. To me, a tick is instantaneous. Oh well. Right. So this has been FATLEG, leg 16. I'm not sure if this is a good solution, but this one is mine. So I guess I'm looking forward to corrections in the comments.